So question 8 is a projectile motions question. So we have two particles, P and Q, projected from A and B, and they collide after 3 seconds, but Q is delayed by 1 second. So the first thing we can do is we can write SUVAT tables for each of them in both the X and the Y direction. So X, Y, SUVAT, SUVAT. And I'll do it here. Now the one thing that will stay consistent is that acceleration in the X direction is 0, acceleration in the Y is always minus G, 0 minus G. This would be T, T, and then T minus 1. Now here would be U cos 64 and U sine 64. Then we have 38 cos 64 for the, cos 41, which is 28.68. This, and then 38 sine 41 is 24.93. We have SX P, SYP, SXQ, SYQ, and then the V doesn't matter. So if they collide, then SYP is SYQ at the point of collision. So we have that, we know that our key formula is UYT minus a half GT squared. So we have UY, which is 24.93 by 3 minus a half G by 3 squared, is U sine 64 times 2 minus a half G by 2 squared. So 24.93 times 3 minus a half times 9.8 times 3 squared is 30.69. Is equal to 2U sine 64, and this is minus 19.6. So 50.29 is 2U sine 64. So dividing by 2 sine 64, we get U is 28 to the nearest whole number. So that's fine. We got that. Next, calculate D. So D is the distance between them. So SX1 plus, or SX for P plus SX for Q is D. Now we know what this is. So SX equals UXT. So 28.68 times 3 plus, now this would be 28 cos 64. This would be 12.27. So 12.27 times 2 is D. So this means that D is 28.68 times 3 plus 12.27 times 2 gives D as 110.58 meters. So in terms of I and J, calculate the velocity of P and Q and the balls collide when T is 3. Okay, so the key thing to note is that Vx is Ux, and also that Vy is Uy minus GT. So for P, we're going to take to the right as positive. So we know that P will have its velocity, so hang on, I'll just write as Vp is whatever its initial velocity next, so it's 28.68 I plus, now we have Uy, which is 24.93 minus 9.8 times 3 is 28.68. Now this could be minus, but we'll just see. So 24.93 minus 9.8 times 3. Yeah, it's minus 4.47 J meters per second. That's the velocity of P. Now, the velocity of Q. Now, because it's going the opposite direction, it's actually going to be minus u cos 64, which is 12.27. So it'd be minus 12.27 I plus, now uy is 28 sine 64, which is 25.17 minus 9.8 by 2. Now 25.17 minus 9.8 by 2 is 5.57, so plus 5.57 J meters per second. And those are the velocities of the particles. Next, calculate the dot product. So Vp dot Vq is AC plus BD, where we have AI plus BJ and CI plus DJ. So we have 28.68 times minus 12.27 plus minus 4.47 times 5.57. So 28.68 times minus 12.27 plus minus 4.47 times 5.57 gives us to the nearest, let's go to the nearest, so minus 376.8. And to otherwise calculate the acute angle. So we can write that cos theta is V1 dot, or Vp dotted with Vq, which we've already found out, all over the magnitude of Vp times the magnitude of Vq. Now the magnitude of Vp is 29.03. We'll do the 2 decimal places. And then the next one is 13 point, no, we're doing this, so 13.48. So cos theta is minus 376.8 over 29.03 times 13.48. So this is peculiar. We have cos theta as minus 0.96. Now when cos is negative, you get an obtuse angle, but it's telling us to calculate the acute angle. So theta, if we do cos inverse, it gives us 164.3 degrees. Now, sort of if we sketch these vectors, so it's obviously not going to be to scale, but minus 12 plus 5 is going to be a long one over here. And then this one is a big I, and it's going to be inverted J. So it's going to be like there-ish. So the acute angle between them is actually none of them, because you have this angle, which is the 164.3, looks like. And then the other one around here, which is 360 minus 164.3, which is 195.7. So it's not the angle between them, and it's not this angle either, because these two angles are different. So the answer I'm getting is 164.3 degrees. So do let me know if there's a problem, but that's what I'm getting. But that's the final answer to question 8.